Hello everyone. When we get a new data set, we really need to get some descriptive data, such as the mean, the variance, and the standard deviation of the data set. R offered some functions to help us to get these basic statistics. So in this lecture, I want to talk about how to get basic statistic data about a data set. First, the mean function. Mean can calculate the average of a data set. In the example on this slide, we have a data set called the fitness app. In this data set, we record each user's usage hours of a fitness mobile app. Suppose we want to calculate the average usage hours among our users. We can use the mean function. Let's try out this code in the R software. First, please download the source data fitnessapp.csv file into your working directory. And then we want to import this dataset into the R software. Let's create a data frame called fitness. And then we can use the read.table function. The file name is fitnessapp.csv. The separator is a comma, and then the header should be true. We brought the source data into the R software. Now we want to take a look at the data frame. Let's use the head function. We can take a look at the major structure of this data frame. Inside of this data frame, we have a vector called hours. We record each customer's usage hours. Suppose we want to calculate the average usage hours. We can use the mean function. We use mean, and within the parentheses, we type in the data frame name, fitness, and then a $sign. Do you still remember the function of the $sign? Yes, we want to access to a vector inside of the data frame. After the $sign, we should type in the name for the vector which we want to access to. In our case, it should be hours. Press enter, we'll get the average hours is 6.7 hours among our users. This is how we use the mean function. The mean function is very simple to use, but we do need to consider one point. What if we have a missing data in a data frame or a vector? In R, we use the symbols NA to represent missing data. In the future, if you see your data set has NA, that means you have missing data in the data set. If you have missing data in a data set and you want to use the mean function, you would probably get NA as the final result, because the mean function cannot calculate the average value for a data set with missing data. How can we process a data set with missing data? For mean function, we have a parameter called na.rm. This means we want to remove the missing data from our data set. If you want to calculate the average value for a data set with missing data, you want to set up na.rm equals to true, as you can see on this slide. Let's see this example. Suppose we already recorded the customer's weights. As you can see, inside of this vector, we have a missing data value. If you use mean to calculate the data set per weights directly, you will get NA as the final result. That's why when we use the mean function to calculate this data set with missing data, we must indicate na.rm equals to true. By doing this, we can remove the NA from the dataset and calculate the average value for the rest of the dataset. Let's try out this code in the R software. We can copy this dataset from the PowerPoint into the R software. Now we have the pro-weights vector. If we use the min function to calculate pro-weights directly, we'll get NA as the final result. Now let's try what if we indicate NA.rm equals to true. Now we get the correct answer. NA.rm equals to true basically will remove the NA missing data value from a vector or a data set, and then calculate the average value for the rest of the data set. This is how you handle missing data in a data set. Another important basic statistics are variance and standard deviation of a data set. These two values indicate how data in a data set change around the mean. To calculate variance, we use the VAR function. To calculate standard deviation, we use the SD function. Notice that in both functions, we use NA.rm equals to true to handle missing data. These two functions are very simple to use. Please try out these two functions after the lecture. I will not repeat how to use them in this lecture. Next, I want to introduce a very important concept, the analysis of variance tests, to everyone. The purpose of this test is to compare the differences between two or more groups. We use AOV function in R to perform this test. In practice, the analysis of variance is usually called the ANOVA test. This is the short name for analysis of variance test, ANOVA test. Even though it is called ANOVA in practice, when you perform this function, the function name is still AOV, not ANOVA. Please notice this point. I want to use an example to show everyone how to use the AOV function to perform an ANOVA test in the R software. A developer is curious if there is a usage hour difference among users from Texas, California, and New York City. Since the developer cannot survey the entire 2 million user population, she draws a sample of 10 users from the 3 states to test her hypothesis. Her hypothesis can be listed as the 2 on this slide. The null hypothesis is there is no difference of usage hours among users from the 3 states, as you can see here. This is the null hypothesis. The alternative hypothesis is the usage hours in the 3 states are not the same. We want to use the AOV function to test this hypothesis. Let's develop this test in the R software. First, please go to eCollege and download the source data fitnessaov.csv into your working directory. Next, we want to bring the source data into the R software. Let's create a new data frame called AOV fitness. And then we want to use the read.table function to retrieve data from the source data. The source data file name is fitnessaov.csv. The separator is comma, and header equals to true. Next, let's take a look at the data frame. Let's type in AOV fitness directly. As you can see, we drew a sample of 10 users. For each user, we ask where he or she is from, which state he or she is from. The first customer is from Texas, the second one is from California, the third one is from New York City, and so on and so forth. Based on these 10 samples, we want to test a hypothesis. Our hypothesis is, if there is a difference in usage hours among the 2 million users from 3 states, we want to use the AOV function to test this hypothesis. First, let's create a variable called AOV result. This variable will hold the analysis result we get from the R software. And then we want to type in AOV parentheses. This is how we use the AOV function in R. In this function, we want to specify 2 parameters. First, we want to type in hours, and then a tilde sign, and then state, and then a comma. By doing this, we want to ask the R software to group customers according to different states they are from. Then we want to compare the usage hours from different states. The AOV function will test if there is a difference in hours from different states. Next, we want to indicate the source data frame. In our case, the source data frame is called AOV fitness. So after the comma, let's type in AOV fitness. And then press enter. Now we already get the results from the AOV function. Let's take a look at the result. We will be using the summary function. Let's type in summary and then parentheses. Between parentheses, let's type in AOV result. When you get the result, the first parameter you want to look at is PR. This is actually the p-value for this test. After you get the p-value, you want to compare it to the level of significance. Remember the following rules. If p-value is less than the level of significance, then we can reject the null hypothesis and keep the alternative hypothesis as the final conclusion. If the p-value is greater than the level of significance, then we fail to reject the null hypothesis. In other words, we have to keep the null hypothesis as the final conclusion. Some classmates may have a question about the level of significance value. What should be the value? You have 2 options. You can choose either 0.05 or 0.01 as the level of significance value. Let's use 0.05 as an example for this question. We get the p-value as 0.77. It is far greater than 0.05. So p-value is greater than the level of significance. We fail to reject the null hypothesis. What does this mean? Let's go back to the point. The null hypothesis states that there is no differences in usage hours among users from the 3 states. Some classmates may have another question. Are you talking about the 10 users or are you talking about the 2 million users? Remember, when we perform a statistic test, we care about the population. We only use the 10 user as a sample to predict the 2 million user population. So finally, we can say there is no differences among 2 million users from the 3 states. This is how we perform the ANOVA test.